All right, everyone. Welcome. I'm the founder of H Industries. I was a UNSW mining engineer. I'm here today to talk about enabling off-Earth mining. Everyone has looked at what to do when we get there, or how to get off-Earth, but no one has looked at the bit in the middle. So I think I might have a solution to that, because doing a single mission-specific propulsion every single time is not how we scale things. So we all know space is accelerating rapidly. In the past, it was exclusively the realm of government, until 1984 when Arianespace had the first commercial launch. Since then, in 2017, it is only accelerating further. Now, the easiest way to de-risk new missions into the highest risk environment that we know of is by deploying existing tech. Not trying to reinvent the wheel. Maybe reconsidering the rubber composition, but that's about it. Now, that symbiotic relationship between Earth and space has given us Velcro, it's given you all the maps in your pocket that you use to find how to get here today. And I think it's pretty clear we're moving into the space economy, where all Earth-based businesses will touch space-based services, whether they know it or not. Now, as I said, we know all that. So what am I doing about it? I came up with an idea after following reusable rockets and their development from 2010 onwards. And in 2015, I was thinking, why can't we just use particle accelerators? We've got high-strength magnets. And then I did a bit more homework, and I couldn't break the idea. And so I came up with a way to move bog standard ISO 668 shipping containers. Now, as the cost of getting into orbit is dropping drastically, I think our system could become the cargo ship, or the freight railroad, not like the FedEx for people the rockets are. Now, slow, efficient, high-mass freight transport is a huge gap in our industry. But what do we do with it? We've heard fantastic presentations today, tomorrow, and all over the coming week at IAC. And I think if I can solve this bit in the middle, we have plenty of companies that are looking at moving robotics, moving drills, or bringing back containers of resources. So why not plug into the standardized logistics industry as is? And that's where we come in. H Industries will offer propulsion as a service. Now, all right, enough talking. Show and tell time. This is not physics accurate, so I'm working on a new video. Yeah, right. If we can push tiny little electrons around a 27-kilometer ring at CERN, you need about 100 million times less accuracy to do this. So we can pull this off with the novel construction of existing technology today. It might sound a bit crazy, but let's see it work on a desk. Oh no, wrong button. Let's see it work on a desk. Right, you put an uncharged ring on a coil, charge the coil, juice current, whoosh it. When you cool it down, you drop that electrical resistance. You induce a greater current, greater field. Look how long it takes to catch. Pretty cool, right? Kind of cool. In geo, nice, relatively stable. So I think we can pull this off today. And if you really want to know the physics, come grab me afterwards, but let's press on, because we've got to talk a little bit about where the company's at and how we're going to get it done. Now, for all the miners in here, we are effectively in pre-feasibility study. We are trying to de-risk our scoping study, and I'm partway through my PhD building a model of this system. We have a huge mass power budget, so we plan to host as many third-party sensors under our wings as possible to generate ROI on data while we're waiting on a physical load to come back. We have got a plan for civilian and defense customers as well, so if you're interested in that, come grab me as well. But I'm trying to get a prototype funded. I think from funding, in about 3 years, we can then prove that this works. We can prove that we will build the infrastructure backbone that enables off-Earth mining, enables you to bring back the samples you want or the materials you want, or send a couple drills from Komatsu, which I'd love to see. Now, I've spent enough time underground for drill and blast, and that leads you to dream of space and getting out a little bit further. So I think for the foreseeable future, every single space mining company is going to be reliant on an earthbound stream of components and then an earthbound ROI. But let's move on. how are we actually going to pull this off? Morgan, this seems crazy, right? You want to use particle accelerator magnets? Well, I'm actively seeking angels and investors. I'm doing a PhD delivering the software to make sure this works. And part one starts with the solenoid. If we can get a superconductive solenoid, we can prove the physics works. If we have 15 mil, we can build a whole satellite and prove that the function works overall. And my PhD research is in digital twins of big data systems. So, Irvin. One of the things is I've planned for 112% project contingency. Because anyone who's worked in R&D, like I have for the last couple of years, knows it does not go to time. That's about the only thing that you are guaranteed. So once in orbit, we can generate ROI. We can do 6 test functions to prove that this works. And then we're going to go out for 150 mil to try and build 10, put 5 in Luna, 5 in Geo, and then we can move a cat truck, or, in bits, or a couple Komatsu drills, or almost anything else that anyone wants. But unfortunately, then comes the big ticket. Now, as you scale it, you increase the rate that you're able to send. And the real smarts of what I figured out is how to keep this thing in space, not actually send it. We've built this particle accelerator almost the same way since the 60s. Now, as a mining engineer, you look at a block cave, right? And you go, 90-odd% of its capex. You drill down underneath, you knock out the bottom, you collapse the whole thing on top of your head, so you only get one go at that geotech. And you can pull rock out for less than $1 a ton. It's crazy. This is how we solve things at scale. The only problem is you got to spend a few bill up front, but that's what we're trying to deal with. So next we aim to raise 1.86 bill, and that will allow us to do daily launches. We want to do away with launch windows. We want to send stuff slowly, efficiently, and you know what? If it takes 4 years to get there, so what? You can build entire bases and containerized businesses and mimic what we did as Antarctic explorers. Except unlike Shackleton, Scott, and a few of the others, you're hopefully not going to lose them. But what's next for right now? Finishing up my PhD over the next couple of years, we're going to raise funding, and then hopefully it's off to the races. And as a little side quest, I would love to see a spaceport built in Broken Hill. It's a town that's close to my heart. It's the center of 3 states. Heavy rail, heavy manufacturing, and I've delivered Orica's R&D into the field there for years. So as I said, thank you for your time. Thank you for Circa and Andrew and the School of Mining for putting this on. And if you want to know more about anything, come grab me.